Welcome back to Building Trust with Built Environments. Today's topic is on novel approaches to product testing. If you've been wondering just how product manufacturers work with companies like ours to test their products to meet code standards, we got you covered. Okay, Steve, much of your past work has focused on novel testing of products and materials. Many of these are not standard methods. What's the driver behind this?
After 25 years in building forensics, I've learned that code-accepted products simply do not work the way we think they do. There's a misalignment between code intent and actual product performance. In other words, products may meet the letter of the code, but they don't necessarily meet the intent of the code, which is arguably more rigorous.
Yeah, well, that's interesting, but also a bit troubling. How do we get back on track? How do we realign products with code intent?
This misalignment reflects testing standards that do little to predict how products perform under real-world conditions. The only way to improve predictive value is by testing differently. And we do this by integrating greater test rigor, longer test duration, and better resolution. We also test complete systems. For example, if a water-resistive barrier requires tapes and liquid flashings, well, it's important to include the WRB and tapes and flashings in that testing. Using these approaches, we identify a system's inherent weaknesses. And it's at this point that we can learn, optimize, and we can improve.
Yeah, that's very interesting. You have made a compelling argument for testing more rigorously and a straightforward approach to doing so. All right, I am really excited about this next part. I understand you are going to share with us a method that puts these concepts into action.
That's right. I'll demonstrate a novel test method that I've developed for this purpose. It's called the face column, and it's been instrumental in identifying a number of shortfalls in water-resistant barriers, tapes, and liquid flashings. I've also used it to demonstrate some truly remarkable products.
Exciting. Can you show me?
Yes, but first, I want to show you the old way of doing things.
Okay.
This is a hydrostatic pressure column, and this column is typically filled with water to about 21.6 inches and allows us to test water-resistant barriers, tapes, and flashings, but it's a very small apparatus. Let me show you how I do it with the face column.
Let's go.
So Bree, here's the face column.
Here it is.
Yeah, let me set this up for you here. What we have is an integrated water-resistant barrier system. The substrate happens to be gypsum here, with an adhered coating or a membrane. I have an acrylic sheet that's adhered to it on 3 sides. So now we have basically a basin that holds water, and it's spaced off from the surface of the water-resistant barrier. So I can fill it with water, hold it to whatever height I want. I can make this the width of whatever I want and the height of whatever I want. So let me fill this up with a little bit more water, just for the sake of demonstration.
This is a really cool visual test. I'm just noticing how much of a larger test it is. Like the surface area is so much greater than that one you had shown me before. Why is that?
Exactly right. I designed that on purpose like that because basically these water-resistant barrier systems, they require tapes and fastener treatments. With a larger surface area, I can integrate all of those components, and that's vitally important.
Oh no, that makes so much sense. With this size, you can do real-world applications and test the tape and all those things to see how they actually work.
Exactly right.
That's so cool. All right, let's go back to the lab. Wow, that truly is thinking outside the box, or as you would say, thinking differently. So how will thinking differently change the industry?
Well, our industry is entrenched in the status quo, the idea that it's good enough or it's always been done like this. But we know this kind of thinking just doesn't work. It's not aligned with the code intent, and it's certainly not aligned with today's high-performance building initiatives. Buildings continually fail, and untold resources are continually lost. It's time for a change, and that change can only come from thinking differently.
Wow, yeah, it sounds like it is time for a change if we want to build smarter. Next time, let's get into some of those misalignments of codes, but until then, subscribe to follow along. If you have any questions, send them in to our team at Built Environments.